What's up, guys? So today what we're going to look at is SohCahToa and basic trigonometry. By the end of this video, you should be able to work out any side or length or angle of a right-angled triangle. So SohCahToa, what does that really mean? Well, let's draw a triangle first and foremost, where it has a right angle and it has an angle x. Remember in my Pythagoras theorem video where I said that this is the hypotenuse, this is the opposite, and this is the adjacent? It's because this is opposite the angle that we're looking for, and this is adjacent to the angle that we're looking for. So we can use this to our advantage by using some trigonometric functions. Sine of x is just going to be equal to opposite over hypotenuse, SoH. Cosine of x is just going to be the adjacent over the hypotenuse, Kach. And finally, the tangent of x is going to be the opposite over the adjacent, Toa. So let's look at some examples. Here we are told that we have an angle 60 degrees and we have a hypotenuse of 32. So what is x going to be equal to? Well, we're looking for the opposite, right? And we have a hypotenuse. So this is our opposite, this is our hypotenuse. So sine 60 is going to be equal to x divided by 32. And now all we're going to do is solve this equation. So if x over 32 is going to be sine 60, then x is going to be 32 times sine 60. It's exactly the same as we did in a previous video where we just times both sides by 32. And so when we plug this into our calculator, we get an answer of 27.7 centimeters. What about this example? ABC is a right-angled triangle, and we're trying to look for what BC is equal to. Again, let's look at BC. BC is adjacent to the angle that we have, and obviously 16 is the hypotenuse. So therefore, cos 38 is going to be equal to our adjacent, which is A, over 16, which is our hypotenuse. Okay? And again, we're going to solve this equation for A. So let's times both sides by 16 to make A the subject. A is going to be equal to 16 times cos 38, which is equal to 12.61 centimeters. So 2 decimal places. What about something like this, where we're told that we have an x and we have a 4? Well, this 4 is, again, adjacent to the angle that we have. And x is the opposite. So therefore, tan 15 is going to be equal to our opposite x over 4. And just like every other example that we've done, we're going to solve for x. So if we times both sides by 4, we get given x is equal to 4 times tan 15. And 4 times tan 15 is equal to 1.07 to 2 decimal places. Also in centimeters. Okay, so now you know how to work out the sides. What about the angles? Well, what we're going to do is we're going to do the same as we've done before. We know that The opposite is, we don't know. The adjacent is 6.4, right? And the hypotenuse is 9.6. So we do the same as we've normally done. Sine, no, we're not going to use sine. I just caught you out there. We're going to use cos. Cos x is equal to adjacent, which is 6.4, over 9.6, which is our hypotenuse. However, we need to make x the subject. We only have cos x. So all we're going to use is something called the inverse cos function, where if you press shift on your calculator, plus the cos that you have there, you should get it. So what we have is that inverse cos x is equal to the inverse cos of 6.4 over 9.6. And when we plug that in, we get an answer of 48.2 degrees to 1 decimal place. Okay, so it's literally the same as what we've done before, only this time we're using the inverse cos function. What about something like this? Well, we have a hypotenuse, we have an adjacent, so it's going to be cos again, right? Cos A is going to be equal to adjacent over hypotenuse, so 12 over 13. And this time we're going to use the inverse cos function. So A is going to be the inverse cos function, so cos of -1 as some people call it. I don't like calling it that, but some students get it like that, so inverse cos of 12 over 13. And once we do that, we get an answer of 22.6 degrees. I will show off how this works in a later video. But for now, this is our answer. 22.6 degrees to 1 decimal place. What about something like this? We have a right-angled triangle, right? And we have an opposite of 3.4, an adjacent of 4.7. So we're going to use tan. Tan x is going to be equal to 3.4 over 4.7. And again, we're going to use the inverse tan function. So it's shift plus tan. That's what the button should look like. So what we're left with is x is equal to the inverse tan. Sorry, I wrote 10. The inverse tan of 3.4 over 4.7. And once we do that, we are left with an answer of 35.9 degrees. So all we've done is done exactly as what I've taught at the start, which is that sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. And we've just applied it and found the inverse to work out what the angle is. Thank you guys for watching. I hope that this video made sense. If you guys liked it, please subscribe. It means the world to me. If you guys need some individual help, join my Discord server. And if you have any further questions, ask me in the comments down below. If you guys need some inquiries about tutoring, drop me an email and I can give you a meeting and a quote. Keep on learning, as you have no idea what you're capable of doing.